So, as usual, we'll start off with a bit of background and history, and that will begin with early computer vision. So, first, I'll take you even further back than I have previously, and that will be with Ada Lovelace and Charles Babbage. Ada Lovelace is considered by many to be the first computer programmer, which is a very interesting notion because during her time, there were no computers. This was, mid to late 1800s. The idea of a computer was just, a theory. There was no real world computational machines until the time of Charles Babbage. And they were contemporaries and had communications and things of that nature. Ada Lovelace actually formalized the first computer programs on paper, before we had machines that could actually run them. And Charles Babbage is best known perhaps for his analytical engine, which was, essentially the first, full-featured computer. It had the ability to do things like for loops, functions, while loops, etc. It had a analogous memory, so it had RAM. It had an analogous mechanical version of storage, and this is a very interesting machine. The full machine never actually got built because the way he designed it, it was a huge monstrosity. Some smaller prototypes were built, but I do encourage you to look it up because it's at the basis of what we're studying, and it's quite interesting. All these what we consider to be quite abstract were actually just raw mechanical things. Functions were handled by punch cards. The placement of the holes in the punch card would determine whether it was an integer or whether it was a mathematical operator. And the composition of this machine was just very, very intriguing and revolutionary for its time, definitely. But then moving on, the Dartmouth Conflicts of 1956 is really where the field of AI started. It was composed of the who's of AI at the time and included experts from some other fields, including mathematics, neurology, neuroscience, computer science, etc. And it included, heavy hitters like Marvin Minsky, who I've mentioned in previous lectures, who was, sort of a sour figure in the field of AI. But this is where, they got together, started contemplating and brainstorming, the future of AI, how to tackle these hard problems, all with the intention of strong AI at the end of it, or, you may know that as AGI. And following that, in the late 50s, early 60s, machine learning and computer vision really took hold, but these ideas were conjectured on far earlier, and this is during the time of Kurt Gödel and Alan Turing, who I'm sure you know who Alan Turing is, maybe not Kurt Gödel as much, but Alan Turing is the father of the computer. Turing machine basically formalized all the mathematics behind computation and computing in general, with the help of Kurt Gödel and others. But even then, they were starting, this is around the 30s, 40s, they were starting to theorize about how they might teach a machine to think and to act in the world on its own volition. And Kurt Gödel is, an extremely, extremely important mathematician and logician, perhaps best known for his incompleteness theorems, which state that given any sufficiently powerful system of mathematics or logic, there exist statements from which cannot be proved in that formal system of logic. So essentially what he did was develop an encoding by which he could use numbers to talk about numbers. So he would encode things like mathematical operators as numbers, and every statement, every operation would have its own encoding, its own. What he used was prime numbers. It's called Gödel numbering, and this was quite the breakthrough, because now you could use math to talk about math, and you could essentially prove, disprove, say things are impossible just by comparing these encodings known as Gödel numberings. A huge subfield of mathematics and logic, and it creeps into everything from physics to computer science to even artificial intelligence. I encourage you to do further research on that. So the original goal of the field was to completely mimic the visual system. That was obviously quite a lofty goal, seeing as we have not, as of yet, gotten close to mimicking the human visual system in totality. And these days we tend to focus on sub-problems, things like object detection, image classification, etc. The over-optimism, which I sort of hit on there, but it was rampant during these times, and it's perhaps best illustrated by the 1966 MIT Summer Vision Project, which had the goal to solve the entire visual system, not just most of it or some major sub-problems, all of it in a single summer. And these were some of Marvin Minsky's students. He seems to come up everywhere in the early years of AI, but some of his PhD students grouped together and tried to break down the human visual system into sub-problems with the eventual goal of completing it by the end of the summer. And obviously that did not happen. We are still hard at work on cracking, visual systems in general, and general machine vision, and, still have quite a bit of trouble with, sub-problems there. So it really just shows how wrong predictions can be. It's always best to hedge your bets whenever possible. If you're not absolutely certain as far as, your predictions, it's probably best to hedge your bets, because you can end up looking, pretty dumb. So early approaches to the problem involved methods from computer graphics, where, in general, the algorithm was trying to learn from entire scene. Generalized scene understanding and sentiment was, some of the major problems that were at least attempted to be tackled. But shortly after that, we learned at least, the algorithms of the time were not up to the task, and, we would have to attempt some lower level analyses of simpler problems. Okay, so following those, rather abstract approaches, we implemented more rigorous mathematical techniques, and many of those are still in use today. Things like SIFT, Viola-Jones algorithm, and a lot of them are available in OpenCV, which is a Python package that utilizes a bunch of classic computer vision algorithms for use in object detection, image segmentation, thresholding, things of that nature. And after these new methods, as seems to be a cyclical occurrence in the AI field, an AI winter came into being, which saw another regression in funding and another downturn in computer vision, and more generally artificial intelligence research. The new millennium is, where everything started picking up, not just in computer vision, but in the rest of artificial intelligence and machine learning. But since 2000, we've seen an explosion that's only been rivaled by that golden era of the late 50s, early 60s, where tons of algorithms like search were, solving simpler contexts of computer vision and reinforcement learning problems. But now we're starting to see, deep learning algorithms solve quite complex problems where, there's millions of parameters, maybe thousands of classes that they're trying to classify to. So we made a good deal of progress, but there's still a lot to do. And this has mostly been led by convolutional neural networks, but more recently, breakthroughs like capsule networks have really pushed the envelope even further. I will try and discuss those, and I should have a good deal of time in the next lesson to dive into capsule networks.